Alright, we're going to square up these blanks material just to get them in a rough squared shape. Put those in the vise. Just tighten it up, and I'm going to, I'm not worrying about the way it's setting, just so that it's got a hold of it here. What I'm going to do is come in here and skim the face off and take an end mill and cut as far as I can down here without hitting the vise jaws to establish two parallel surfaces and make them, of course, perpendicular to this face. So we'll start with on both the pieces. I got two pieces of material like this. I think this material is 4340 steel. It's probably not heat treated yet. I think it's normalized, I believe. It's a scrap piece, a couple of scrap pieces I already had, and we cut them up in the saw out of, well, it was a big chunk, what was left over of a forging. So I'm going to change to the face mill. We're going to skim off this face, and then I'll find an end mill where we can cut these two edges in the tool changer, and we'll do that, and then we'll flip it over and set it on parallels on this face, clamping on those milled surfaces, and face the other side parallel, and then we can stand it up in the vise to face the top and the bottom off of it. 53 is my face mill. Let's change to that. I'm going to just do all this manually. Start the spindle 600 RPM. I'm going to manually jog this down in Z with the hand wheel here until I touch. And then we're going to take a skim cut across the face just to see where we're at here. I'm going to feed it with the machine over here. Okay, now we got to, let's go to the back of the tool changer and we'll take a look and see if we can find an end mill that'll work for this. Here, show you the tools. Let me see if I can find a tool. This one might be good. Just need something to skim the... Okay, that's tool number 6. I think that'll work all right. So let me change to tool number 6. We just got to get a couple of good surfaces here. So I got to call tool. Let's hit T, and it highlights the T. 6. It's going to bring it up into the arm of the machine, and then we're going to over here we're going to go to edit. Up here. I'm going to let it come into the arm before I hit any reset or anything, so that can mess the tool changer up. I don't know if you can see over there. See, the magazine's going around. Okay, that's going back to tool 53's location. I don't like to hit, I could do it, but I don't like to hit reset when that tool magazine is moving. Sometimes that can mess it up. I can hear it. Okay, now reset, and we're going to go input, MDI setting complete, MDI. We'll change to that tool. Okay, that's the end mill we want. We're going to skim this off till it cleans up, and the bottom till it cleans up. And kind of see where I'm at here. I want to see if I can get below that scale on the surface here. All we were after was to get two good clamping surfaces that were perpendicular or as best as possible to this skimmed off face and parallel to each other. So when we flip this part over and we put it in the vise on parallels and grip as much of this as we can skim the other face off parallel to the top here, and then we can stand the part up in the vise and we got something square to work with. So now we gotta do the same thing to this part here. So I won't show you that, it's the same. And I'm gonna come back with the setup after that. Here's the next setup. Put it on parallels, top and bottom, and we've gripped about a ½ inch of this length that we milled on the two sides to make them parallel, so we have something to hold on to. Now we're gonna face this down to 3 inches thick. Here is what my blank requires for this part, and then we're going to stand it up and face the height to the proper height, and also cut the ends square. Three inches here. Doesn't have to be perfect. 3 inches 1/1000ths. Good enough. Put down a little bit here. Check my parallels. I'm going to tighten it pretty good. And I'm going to cap it down again. See how this parallel is loose on the bottom again? I want it to be tight. I'm going to tap it down. Now they're tight. That's important. If your part's not very thick, you know, if it's thinner, how much you tighten the vise here can bow it up. This is such a thick piece of material, it's not critical, and it's only the raw stock. I'm just roughing a blank out for going on the fixture on the Mazak, but if you were doing a finished part or something, and the part was thinner, it would be a good idea to, you could clamp it tight to rough off the material you want, but then leave some stock and then loosen the vise and snug it back up and tap it back down on the parallels, and then take your finished cut, because it will bow out the middle of the part and it'll be thin. It won't be on this thicker part, but in a thinner one, you can make it thin in the middle because it's actually bowing it out. actually the B0 direction. This face of the tombstone is facing the 0. Get back here out in the middle. Roughly the middle. Not too bad. Let's go up and down. I'm sure nothing went weird with this. Alright, well, make sure we pay attention to what we're doing better here. There's what do those people call it, Mr. Bozo attacks again? Alright, I set a mill stop up here, if you can see that. So I can kind of base both these to the same length over here. And I turn the part up vertical so I take less passes across it. Mr. Bozo struck there, as you saw. I would be paying attention more to the handle jog and less to the camera. Probably wouldn't have made that mistake, but everybody makes mistakes. It'll be annoying to look at from now on to me, but it doesn't really hurt the function of the vise. But just so I'm going to show it in the video, just so you know where that big old gash comes from in the vise. The thing is, with this handle jog, you'll be careful not to spin the wheel, particularly if you're in the Z-axis jog. I thought it was in the X, and I spun it to minus to move the tool this way, and I was in the Z. And that's what happens. I'm going to use this part as the control length because it's a little bit shorter. Right there on that corner. Here's the stock for the fixture in the Mazak. It's an 8.5 inch round 140 commercial heat treated bar. I'm going to turn the dovetail to clamp it in the chuck jaws on this end that we're working on right now. Kind of have poor chip control there. I don't have the right insert, but we're just going to power on through it. It's not that much turning here. I think that's some insert I normally use on titanium or something like that. Now we're going to come in with the, this is actually the finishing tool, but I'm going to rough out the angle of the dovetail first, because it can go down the 30-degree angle the dovetail has. Not really getting great chip control here either. But it doesn't really matter, it's just a fixture. I'm not, going for some production or anything, so I'm not worrying about it. This is just some scrap piece of material we found around the shop here. It was a drop off the end of a bar that they had here at Centerline. Okay, there's the chuck jaw. It has to fit that angle like that. It comes up against the face of the jaw, not the the counterbore side, if you will. This is just milling some kind of some starting holes for the drill. I like to start I'm going to drill these holes with a spade drill, and I kind of like to start the a spade drill in a small counterbore like this. They tend to wobble around a lot if you just start them maybe on a spot drill, a small spot drill or something. The things will shake around and the front of the hole will look kind of, I don't know, it looks crappy. So I usually mill a little counterbore like this. That's the size of the drill. In this case, I think it was a 1.25 inch drill. It's a 1/2 inch Anvil. And that way the drill gets into that full diameter. Actually, if it's just a hair under this drill size, it even works kind of pretty good too, because the drill kind of reams it out on the front of the hole. If you don't do this with a longer drill like this spade drill or something, it kind of wobbles around when it first starts in the hole. You may have noticed this. You kind of get a bell mouth hole with a spiral scratch in it for about the first 1/4 inch of the depth, and then it starts to steady out. So if you do this, you don't have that problem. It's a little bit extra work though. This is just an indicating flat, so when I clamp the thing in the chuck, I'm lined up with those holes that I already drilled, because there's no way to indicate them after I turn it around. And it'll also serve to indicate it in the future if I take it in and out of the chuck. So here's the spade drill. So I'm going to drill the standard one first to depth, and then we come at the flat bottom tip just to flatten the bottom of the hole. So this is, I didn't have a shorter drill, or else I might have been able to get away without this counterbores, but I just had this longer one of this size, so that's what I did. I think I was only going about 6.5 inches deep here, if I remember. It's not really too critical. This is only establishing a flat where my nut and washers is going to go on the other end of the fixture. Otherwise it'd be a lot more complicated to mill that flat area in there. So I just change the tip of this drill to a flat tip. We're going to go in and just flatten the bottom of those holes. So that's about it for this side of the fixture, and then I got to take it out and turn it around and change the jaws on the chuck and indicate it all in and get it running true to that diameter on the OD there, and the C-axis 0 will be at that flat I milled already on the outside diameter. So this is the way the holes look here. I'm kind of trying to show the bottoms of them there. They kind of got a flat bottom. It's not that critical. It's just going to be where the screw that holds the stock onto the fixture comes out. You'll see. So here's the part turnaround, and like I say, indicated in and everything. We're going to turn the OD. Kind of got a taper to it. Tapers down to the smaller size where the stock mounts on it. And it's just pretty straightforward turning here. You might notice I changed the insert. It's got a little better chip control than the first one did. Not getting a bird's nest of shavings there. Although the finishing insert I left the same, so it's not doing any better, really. So to change this to the 1.5" feed mill. Kind of mill a square rectangular boss, I should say, on the end here where the part's going to set, or the stock for the part's going to set, which is actually the base size of the anvil, and then some angles coming off there for clearance of the tooling to go to do the milling on the anvil. Here I had a little trouble with this feed mill. I don't know, I was trying to run it too high in RPM, and flood coolant doesn't really usually work on the feed mill. In fact, it didn't work here at all. It chips the inserts. So I eventually changed to a different grade here in a second, you'll see. I tried that. I was still insistent, although I changed the coolant. No, I didn't change the coolant yet. I think I changed it a little bit later. And right here I stop it in a second. And I try to change the grade of the inserts first. And you'll see I've been putting this kind of yellow coating, like a tin coated insert in there, that one, on the tool, and I tried that. Still wasn't working. And what I ended up doing in the end is getting rid of the flood coolant, which I should know better because flood coolant just doesn't really work on feed mills. And unless you're machining something like Inconel or that kind of thing, then you're running real slow and flood coolant works. But in steel, you're running generally a higher surface footage, and it doesn't work because it heats and cools the insert as it goes through the cut, and it fractures the carbide. Here I changed to air through the spindle by this point, and that worked better, but it still chipped the insert. I had already gone back to the original grade, so it kind of busted the corner off of that insert, and I ended up having to file the pocket a little bit here because it had a burr on it. And what I ended up doing that worked here, this is 4140 commercial heat treat, so it's probably about 36 to 38 Rockwell C. I did tighten the clamp screw. It doesn't show it in the video there, but on the clamp on the top. But what I ended up doing was slowing the RPM down and maintaining the same feed rate. So I had started at about 1200 RPM, and I kept reducing it, and I ended up with 700 RPM on the feed. I mean on the speed, and then on the feed I left it alone. I think it was feeding like I don't know, 50 or 60 inches a minute, and a 55,000 step cut per pass. And once I slowed the speed down, that cured the problem of the inserts failing. People get all wild about high RPMs and feed, you know, speed and everything, but generally speaking, you don't really need all those RPMs a lot of times. This is at the actual speed the tool's running at. The scenes before, or the clips before you just saw, were sped up, of course. And this is pretty much normal the way a feed mill cut looks. It looks like it's chattering, but it really isn't. In fact, I probably could have fed this even faster. Usually with this tool I feed it about 90 inches a minute, and it tends to work better. I just don't know why I was not doing that here. I think it would have been better if I fed it faster. It kind of puts a load on the tool and keeps it from chattering as much. So this is just roughing out these are just pockets for so I can get to the nuts on the screws that hold the piece of material on the fixture. And this will make more sense in a little bit when we see it. And of course I was drilling the holes from the other side just to get the flat surface for where the nut and washer sets. And these notches are just for clearance of the wrench, really, so I can get in there. This is just finishing the rectangular boss around the LD, of course. And then I use this same end mill. I just tipped the B-axis to the, I think that was 20-degree angle to mill the flats. And this is that normal speed here. And after this pass, right there, I speed it up. So it's, I can't remember when I made the video, I think it was 5 times normal speed there. Here I'm going to change to a 1/2-inch ball nose end mill to finish out those pockets, but I had a little trouble with this tool. You'll see in a second. So when I made the first pass in there, we could see to plunge with an end mill, with a ball end mill like it was doing there, into that bigger radius in the corner, broke the tool, broke one of the flutes off the tool. And so what I had to do was modify this and come back and rough out those radiuses in there more. See where I'm pointing with that little pointer? See that big radius? You can't go down into that. And also these other ones, those were smaller. That was the tip of the feed mill, but still I'm going to rough those out a little more so the tool doesn't have to, because it's actually, when it's coming down that angle, it's plunging with the tip of the tool. And a ball and end mill doesn't like that. It doesn't have a lot of clearance in the gullets, in the gash of the tip. So here's another 1/2 inch extended length end mill. I'm just going to rough those radiuses out. So I'm just showing, I'm taking, I don't know if it's 1/8 inch, 100,000ths or 1/8 inch passes with this. It's just pretty much standard. Although there's no clearance ground on the neck of the tool. You see the tool's rubbing on the, and this isn't really that critical. I'm not worried, but I had to run the coolant or it's going to overheat that tool because it's actually rubbing it above. In general, you can kind of get away with this if you have flood coolant running on it, and it's not too much of a deflection where it breaks the tool. So that's the radius is roughed out to a smaller 1/4 inch radius with a 1/2 inch end mill, but there's still stock on there that's got to come off. And then I programmed this, and that probably would have been good enough. I could have lived with that and just deburred it, and that would have worked for the fixture. But for the sake of the video, I guess more than anything else, I want to do this 5-axis cut in these pockets just to finish the inside surfaces. It looks kind of nifty. It's really way overkill for this fixture, but I like to sometimes practice this stuff on parts that aren't real parts, to where if you make a mistake, it's not really a big deal, you know. Otherwise, you don't sometimes get practice on this kind of tool paths. So that's running at actual speed there, and the camera's mounted on the spindle head, so it kind of looks funny, like the tool is not tipping in those views, but it is actually. You can look at the background and kind of see that things are rotating and tipping. Now you can kind of see it there because it's mounted on a stationary mount. So I'm not going to run through all of this in the video. You get the idea. It's going to be too long, extend the length of the video too much. And the way you actually make this work is you put a point out in space up there above the part, and the axis of the spindle or tool has to maintain that point. So if the point's in the right place, in this case, it makes the tool angle away from the sides of the walls like that. The point also rotates with the C-axis, so that's why it actually, the whole Y-axis of this machine is actually going back and forth, because the point out there, it's up above the part about 9 inches is where I put it, up above the I think it's above the center line, 9 inches above. So the tool has to maintain that point in space as it moves back and forth on the axis of the tool. So here's a spot drill just to spot these holes for what I'm using is some drill bushings for the alignment pins, I guess you might call it, but they're hollow, so I can pass the screw to hold the part through it in. This is just a drill, a clearance. The screws are 5/16 18. You may have noticed when I did the material blanks, I showed the gauge. And it's milling a 1/2 inch counter bore for the drill bushing. Actually, I'm recutting it here actually because it was a little tight, so that the bushing would fit properly. A little bit of deburr, and then I hammered the bushings in the holes, but for some reason I miscalculated here somehow, and I didn't make the counterbores quite deep enough. compared to the depth of the counterbores in the part, the stock for the part. And so when I tried it on here, it didn't see, there's that gap. It doesn't go down all the way. It's a little bit tight, but see, it's got a little bit of a gap, so I had to mill off the ends of these drill bushings. And I'd take about 1/16 of an inch off of there. And then deburr them with the NSK grinder. So that's pretty much the fixture, and I'm going to bolt the stock onto that, and the next video is going to be about actually milling these little anvils, that's going to be pretty interesting in itself. There's a lot of 5-axis positioning and the full 5-axis moves in a few spots. And when I got this thing bolted on there, it's really solid on there. If I ever make the bigger anvils, like I talked about in one of my previous videos, this is essentially the way I would do it. So I would have just a bigger fixture like this, hold a bigger piece of material. So that's it for this video. Watch the next one for the anvil itself being machined.